theory of relativity, Albert Einstein redefined space and time, predicting a universe so strange and grand that it challenges human imagination. From an idea born in a Swiss patent office, it grew into a famous theory in Berlin, presenting a completely new picture of the universe, rooted in a new, deeper understanding of gravity. Before that, Newton's law of universal gravitation had dominated for nearly 2 centuries. But Einstein introduced a theory describing space-time, a unified fabric warped by mass and energy. According to this theory, objects bend the fabric of space-time, like weight on a trampoline, and the curvature of the fabric dictates their motion. With this new and profound insight, gravity was explained. Einstein reshaped the universe in an entirely new way. In this video, we invite you to explore Einstein. Wishing you relaxing and beneficial moments. Let's dive in and explore. In late 1915, in a series of lectures in Berlin, Einstein presented his general theory of relativity. But it wasn't until 4 years later, in 1919, during a solar eclipse, that people began to pay attention to his theory. Einstein predicted that a massive object, such as the Sun, could warp the surrounding space-time to bend light from its straight path. Thus, distant stars would appear not where expected. This is a photo taken during the eclipse. It proved that the shift in position matched Einstein's prediction. Shortly after the eclipse, the New York Times ran a headline saying, "All light is askew in the heavens, scientists more or less agog." Even a decade later, the predecessor of Science News wrote about the story. Struggling to understand Einstein's theory, the story described 4,500 people breaking iron gates and trampling each other at the American Museum of Natural History in New York City to hear explanations of Einstein's general relativity. By 1931, Albert A. Michelson, the first American Nobel laureate in science, called Einstein's general relativity an unprecedented revolution in scientific thought in the history of science. With all of Einstein's predictions about the universe, to this day, many nickname him the reluctant prophet. We now know that Einstein's general theory of relativity has brought more than he could have foreseen. Astrophysicist David Perkowitz said that general relativity has some wild implications that even Einstein did not want to accept. Today, general relativity has become the foundation for humanity's understanding of the universe. But of course, that picture is not yet complete. There are still many questions about matter, about mysterious forces, about the beginning and end of the universe, about quantum mechanics, or about the connection between quantum mechanics and the universe, etc. All these questions will be pursued by scientists, pushing Einstein's general relativity to find the missing pieces. Here are famous predictions by Einstein and his general theory of relativity that have been found and proven to exist in the universe. Just over a century after Einstein published his general theory of relativity, scientists captured an image of one of space's monsters, the black hole. In 2019, a global network of telescopes observed a region of space-time warped at an incredible rate. So strong that nothing, not even light, could escape. At that time, the Event Horizon Telescope took the first image of a black hole at the center of galaxy M87, and here is that image. Astrophysicist Akiyama, head of one of the groups that created the first black hole image, said, "I somewhat expected that we might see something strange." After seeing the first black hole image, he exclaimed, "Oh my God, it perfectly matches our expectations from general relativity." As we know, for a long time, black holes were only known as mathematical predictions. Before the first half of the 20th century, scientists had no evidence proving their existence. It wasn't until recent decades that scientists acknowledged these monsters not only exist but also aid in the formation of the universe. Scientists say that objects predicted by general relativity, once mathematical oddities, have become reality. Initially, we only knew them marginally, but now, we have captured an image of their center.
Besides the first image of the M87 black hole in 2019, using similar methods,
by 2022,
scientists had captured the first image of the black hole at the center of the Milky Way, the galaxy containing our solar system.
This is that image. After the photo was released, representatives of scientists from the European Science Council stated, "Even Einstein could not have imagined the things he himself had discovered."
To obtain this photo that this genius thought of 100 years ago, cooperation from 40 countries is required.
It must be admitted, Albert Einstein was truly a genius for predicting with theory over 100 years ago. Currently, scientists have just captured an image of the black hole, the most concrete evidence of its existence. When massive objects in the universe collide, they warp the fabric of spacetime. Ripples in spacetime, called gravitational waves, spread outward. Einstein predicted that such waves could be generated, not only by collisions of massive objects but also by explosions and other accelerating objects. But for a long time, detecting gravitational waves was just a dream for scientists. From the 1950s, when many still debated the actual existence of gravitational waves, physicist Joseph Weber dedicated his entire career to finding ways to detect them. After more than a decade of effort, he claimed to have detected gravitational waves in 1969, when he recorded a clear signal from a supernova or a fast pulsar named PSRV 1919+21. But at that time, he had no way to prove his discovery. At that time, Science News reported, physicist Joseph Weber was believed to have detected gravitational waves. But his discovery was never confirmed and the source of the gravitational waves was not found. Even when he passed away in 2000, these waves had not been verified. As science advanced, scientists developed the LIGO detector, one of the ultra-sensitive devices searching for space-time ripples emitted from black holes or collisions of large celestial bodies. It wasn't until 2016 that the LIGO detector proved effective when it detected gravitational waves
generated 1.3 billion years ago from the collision of two massive black holes.
This was a very important discovery in the field of astronomy, and the Nobel Prize in Physics was awarded to the pioneers who created the LIGO detector.
A few years later, when more gravitational wave detectors worldwide became operational,
scientists detected many more gravitational waves in the universe. They are mainly generated from the mergers of black holes. In some other events, gravitational waves were found from neutron stars. And since gravitational waves were detected in the universe, it once again proved Einstein's predictions about gravitational waves were correct. In the 1920s, Alexander Friedmann, a Russian mathematician and meteorologist, adjusted Einstein's original equations to describe a universe that is expanding or contracting over time. Before that, Einstein was not ready to accept an expanding universe. In fact, He added a constant to the equation to keep the universe static.
This constant is now known as the cosmological constant.
But eventually, astronomer Edwin Hubble made Einstein change his mind. In 1929, with pioneering data from the Lowell Observatory in Arizona,
collected by the most powerful telescope at the time,
Hubble revealed that farther galaxies appeared to be moving away from us faster than nearby galaxies. In a 1930 article in Sky magazine titled "Nebula Holds Speed Record," reporting on a group of nebulae called the Ursa Major Cluster flying away from us at 17,200 miles per second. The article summarized Hubble's findings in the final two stages of the story.
The article states that the meaning of these high speeds has not yet been clearly determined.
The relationship between distance and velocity regarding the propagation of light. Our universe has finally become clear and is expanding like a baking loaf of bread, with galaxies like raisins spreading far apart. Moreover, general relativity had predicted that. Physicist John Archibald Wheeler, who supported general relativity after Einstein's death, called the expansion of the universe the most impressive prediction science has ever made. Since the discovery of the expanding universe, scientists have continued to question the past, present, and future of the universe. Much new evidence and theories have been proposed, such as the Big Bang, the acceleration of the universe, dark matter, dark energy, the cosmic inflation period, or what remains of the universe, etc. Once again, we see that Einstein's predictions were always ahead of their time. The gravitational lens of the universe. Einstein became globally famous in 1919. That year, scientists measured the deflection of starlight as it passed by the sun during a solar eclipse. Einstein's general relativity equations predicted that
light would be deflected twice as much as predicted by Newton's theorem.
And Einstein was right. That was a phrase repeated many times in science news pages at that time. At that time, Einstein not only noticed that gravity could bend light, but also acted as a lens, until a friend named Rudy Mandel persuaded him to write a paper about this phenomenon.
Today, gravitational lensing is considered an invaluable tool for probing the universe.
This is an astronomical phenomenon that occurs when light emitted from an object is
deflected on its path, under the influence of gravity when passing near other celestial bodies.
This phenomenon is more clearly observed if light passes near massive celestial bodies such as supermassive black holes or galaxies.
Then, the image of the light sources is halted, divided into multiple parts.
The supermassive gravity of the foreground objects converged, magnified, and enhanced the brightness. Like a giant lens in the universe, helping us observe the light of very distant objects. Even light sources can be duplicated into 2 or 3 identical images. But in reality, there is only one light source. Those are the features created by the gravitational lens of the universe.
Gravitational lensing is also one of Einstein's famous predictions.
It is also known by another name, Einstein ring. To date, gravitational lensing has been widely applied in searching for distant objects.
One gravitational lens commonly used by scientists is the Able 2744 galaxy cluster. This is a galaxy cluster about 4 billion light-years away from Earth. It has a mass about 2 quadrillion times that of the Sun.
With this mass, it has an impressive ability to bend light.
In 2014, based on the gravitational lens of the Able 2744 galaxy,
scientists discovered one of the faintest and most distant galaxies ever observed.
When the galaxy's light passed through the Able 2744 gravitational lens,
the galaxy appeared 10 times larger and brighter than its actual brightness. Scientists calculated that this galaxy formed very early. It existed 500 million years after the Big Bang.
Using gravitational lensing to observe and look back into the universe's past, helps scientists better understand the formation and development of the universe over time. Besides observing distant galaxies, gravitational lensing also helps scientists magnify stars, planets, probe dark matter, dark energy, predict the future of the universe, etc. It must be admitted that over 100 years since Einstein's theory of general relativity was introduced, many of his predictions have been proven accurate. To this day, it remains the best theory helping scientists explore the mysteries of the universe. Hopefully in the near future, scientists will make more new discoveries to help humanity better understand what has been and is happening in this vast universe. At this point, the video from Part 2b will take a pause. Wishing you relaxing and rewarding moments. Now, please continue selecting videos on the left or right side of the screen to join Part 2b in exploring more mysteries of the universe. Looking forward to seeing you in the next videos. Goodbye.